Hello everyone, this is Akash. Welcome back to this YouTube channel Nursery with Lecture. In this video, we are going to discuss the complete trigonometry ITF, that is inverse trigonometric functions and trigonometric equations. What are the trigonometric formulas are present and what are the inverse trigonometric functions, why it is called inverse trigonometric functions, and also the domain, ranges and graphs of inverse trigonometric functions, and also the properties of ITF, what are the properties that exist in inverse trigonometric functions, why it is said to be inverse, what is the necessary conditions to be an inverse function, what are the domain and range restrictions. These all things we are going to discuss today, and also the properties, and also interconversion idea of how to convert the sine inverse into cos inverse, and also the trigonometric equations, how to solve the trigonometric equations, what are the types present in the trigonometric equations, and also in the trigonometric equations what are the main things you have to remember in order to solve the questions, that is number of solutions, how to calculate the number of solutions. These are all the things I am going to discuss today. But before that, in the previous videos I already explained so many chapters one shot. Basically this is a last topics in the complete change makers batch series. So this is the last day in the complete schedule, that is change makers batch JEE 2023, which I planned for you. So now let's get into this video, and also the previous videos, the handwritten notes as well as the Google form questions I already posted in the Telegram for all the chapters. If you didn't do that, please go and join the Telegram group, and also the practice the Google form questions, and also access the notes which I written by myself. It is very important to access the notes, because in board, if anything misses in the notes, it will be present. If anything, now actually it does not happen like that, but if anything is missing here, it will definitely present in the notebook. It is very important. In order to access you, that you have to join the Telegram group, so it is mandatory. And also if you join the Telegram group, it is very beneficial for you, so you can get the quick update. So now let's get into this video and discuss these topics line by line. Basically you already know that in the 10th class, that is in board exams, you already learned all the trigonometry required in order to get into 11th standard and 12th standard. But when a student comes to 11th standard, 12th standard and sees the trigonometry, his mind was completely blocked, because the trigonometry present in the 10th class is nothing but 0.1% in total 100% of trigonometry. Just 0.1%, because you didn't learn that much enough concepts here in the 10th. But in 11th standard you will learn nearly 7 to 8 chapters only based on trigonometry, that is compound angle, subnormal, these all the things you can learn here. That is 11th standard and 12th standard is very important. So basically now let's discuss each and everything, and at the last I will do some problems also, which is which is required for you in order to get you idea. In here I can't explain all the chapters, I mean all the chapters, all the questions. There are thousands of questions. I can't explain thousands of questions here, but I can give a glimpse of the topics, and also the glimpse of the problems which may occur in future. So basically we can expect that. And also now let's start. Basically the trigonometric formulas for the first division is, that is that is angle division property, that is sine of x plus y equal to sin x cos y plus cos x sin y. This is the formula for sin of x plus y. You already know that. Cos of x plus y equal to cos x cos y minus sin x sin y. These are all the things you have to understand. Sin x cos x over. Next, tan of x plus y. Tan of x plus y equal to tan of x plus y divided by 1 minus xy. Next, fourth one, tan of x minus y. Tan of x minus y equal to tan of x minus y divided by 1 plus xy. Next, fifth one, cos of x minus y. Cos of x minus y equal to cos x cos y plus sin x sin y. Basically I am explaining each and everything to you. Basically you can definitely see that here the sin of x plus y, that is there is a division, that is sin x cos y plus cos x sin y. Basically this is formula of sin of a plus b. You can think like that. It is basically like that. This is a formula for that thing. It is very important for you to understand. Cos of x minus y equal to cos x cos y plus sin x sin y. Next, sin of x minus y. Sin of x minus y equal to sin x cos y minus cos x sin y. It is very important. This is the first set for the formulas. We have to remember these 6 formulas. It is very important. Now the second set of formulas is, that is submultiple, multiple or half angle formulas like that. Suppose if we take sin 2x can be written as 2 tan x divided by 1 plus tan square x, and also it is written as 2 sin x cos x. If it is half angle, that is sin x, it is written as 2 tan x by 2 divided by 1 plus tan square x by 2. And also this is 2 sin x by 2 cos x by 2. If it is half angle, you can get half angle. That is, if 2x is present, like this formula. If x is present, like this formula. So basically this is the formula of sin 2x. So like that, there exist formulas of cos x, tan x, secant x, cosecant x, like that. But we'll mainly discuss about sin, cos, tan, because these are the repetitive values in the examination. So cos x, cos 2x you can take, that is 2 cos square x minus 1. Also 1 minus 2 sin square x. 1 minus 2 sin square x, you already know that. And also 1 minus tan square x divided by 1 plus tan square x. These are all the things, all the formulas that is belongs to tan x. Cos x equal to 1 minus tan square x, and that is 1 minus tan square x divided by 1 plus tan square. Next, tan 2x. What is the formula of tan 2x? The formula of tan 2x is same like this formula only, but a slight change, that is 2 tan x divided by 1 minus tan square x. You can easily verify that sin 2x by cos 2x equal to tan 2x. So 2 tan x, it is simply written as 2 tan x divided by 1 plus tan square x divided by 1 minus tan square x divided by 1 plus tan square x. 1 plus tan square x, 1 plus tan square x cancel. 2 tan x divided by 1 minus tan square x is a formula for tan 2x. This is a formula. Next, that's it. For this section, that is multiple and submultiple, this is enough. You have to just understand the formulas. You cannot mug up all the formulas. There are certain formulas which you have to definitely mug up, but there are formulas like this. You have to just think why it is happening like that. Tan 2x, you can simply write as sin 2x by cos 2x. So sin 2x is 2 tan x by 1 plus tan square x. Cos 2x is 1 minus tan square by 1 minus tan square x divided by 1 plus tan square x. So you can divide and get answer 2 tan x divided by 1 minus tan square x, like that. Now the third set of formulas, that is sin 3x and cos 3x. It is very important. Sin 3x equal to 3 sin x minus 4 sin cube x. Cos 3x, 4 cos x minus 3 cos cube x. These two are the formulas for sin x and cos x. Sin 3x and cos 3x. This is the third set. Next, fourth set of formulas. In these formulas, there is a tan formula also. You have to remember the tan formula. The tan formula is not that much important, so you can verify in the notes which I written. And also now, the fourth set is sin of theta. Sin of 60 minus theta. Sin of 60 plus theta. It is very important formula, because in 2022 JEE mains examination, direct question came from this topic, that is cos of theta, that is cos of 60 minus theta, that is cos of 60 plus theta. If you see these two things, sin of theta, sin of 60 minus theta, sin of 60 plus theta, and cos theta, cos of 60 minus theta, cos of 60 plus theta, you can definitely observe a pattern that here theta, it is an decrement of minus theta and it is an increment of minus plus theta. So basically the total formula for this is 1 by 4 sin 3 theta, and theta is the angle of first value. And also cos theta, cos of 60 minus theta, cos of 60 plus theta. The total answer is 1 by 4 cos 3 theta. So basically you can get the theta from here. There is a direct question from here. So for 2023 aspirants, you can get a question from this. So be aware of the formula. If you keep the sin theta series, the cos formula, you will get the wrong answer. So it is very important to check the what values you are keeping, whether it is theta or you are keeping 60 minus theta. Please check. So if you can take definitely an example of 60 degree. If you take 0 degree, sin 0, sin 60, sin 60. If you take like this example also, what you will get answer? Sin 0, 0. What is 1 by 4th times of sin 3 into 0? That is 0. So I basically explained an example. That's it. So this is the answer. This is the fourth set formulas. And next, there is a huge, because I have to discuss the trigonometry, ITF and trigonometric equations in one session. It is very huge. But you have to understand, this is a one shot, and also the main topics, main key points which are important to you in order to remember to you. The total key points will be covered here. But the silly things like what is sin x, what is cos x, these cannot be done here. This sin x, cos x, I can able to explain, but the session will go lengthy. If the session goes lengthy, you will not see this video and you can skip this video. The reason why I am keeping these short videos is you can easily cover the syllabus, and also you can also gain the confidence. So that is the reason why I am keeping these sessions as 1 hour, 1.5 hours, 2 hours maximum, not greater than 2 hours. It is very important to you in order to do this. And next, and if you see, the trigonometric complete formulas are completed. Trigonometric formulas are completed, but there are so many other formulas which you have to remember. But the main key formulas which you can, which is difficult to remember, I explained here. Formulas are not difficult to remember when you apply in the problems. So you have to apply in the problems and you have to remember, that's it. You cannot mug up all the formulas. There are thousands of formulas in math, physics and chemistry. You cannot mug up all the formulas. You have to see what is necessary and what are the required formulas which we have to mug up, and which we have to do the derivation for that formulas, and which we have to do the problem practice. So if you do the problem practice, the formula is feeded in the photographic memory of you, definitely. So now let's discuss the ITF part. What is ITF? ITF is nothing but inverse trigonometric functions. Inverse trigonometric functions. Inverse trigonometric functions. Why it is called inverse trigonometric functions? The reason is how inverse is existed. If we see the trigonometry, suppose if we take sin x, if we clearly see the graph of sin x is like this. I already explained the complete functions properties. Is this a 1-1 function or many-1 function? To check whether it is 1-1 function or many-1 function, you have to draw a horizontal line. If it is meeting the curve more than 1 point, then it is called many-1 function and not 1-1 function. So sin x is not a bijective function. What is a bijective function? Which is both 1-1 as well as onto. When a function is 1-1 and onto, it is called bijective function, and for bijective functions, the inverse function will exist. So sin x is not a bijective function, so inverse does not exist. But if you restrict the domain of sin x, if you restrict the domain for sin x as pi by 2 and minus pi by 2 to pi by 2, you will observe a graph like this. This is a graph. And when you draw a horizontal line, it is meeting the curve at only 1 point. This is clearly proving that the sin inverse x is possible for sin x. That is, the inverse of a sin function is existing, and you have to restrict the domain. So if you restrict the domain of a sin x, then there is a possibility to exist the inverse function. So what we are restricting, the domain we are restricting, and also the range. What is the range? -1 to 1. So this is the sin x. Why sin x is exhibiting the sin inverse x even though it is not bijective function. We already explained only bijective functions will able to follow the inverse functions. Means you have to, only bijective functions will make the inverse functions, I already said. But here when we restrict the domain of sin x as minus pi by 2 to pi by 2, what will happen? The sin x is exhibiting inverse property. So when we draw the graph of this inverse function, this is a graph. This is normal graph, that is sin x when we restrict the domain. The main inverse of the graph is this. And what is the domain now? What is the domain? -1 to 1 is the domain. And what is the range? Minus pi by 2 to pi by 2. You have to observe very clearly. F maps, that is functions mapping from a to a domain -1 to 1. Minus pi by 2 to pi by 2. It will give -1 to 1. This is for sin x. The description of function is sin x. And if we write like this, minus pi by 2 to pi by 2, this description is for Sin inverse x. C minus pi by 2 to minus 1. So when the inverse function exists, it will reverse. That is minus 1 to minus 1 to 1. That is pi by 2 to pi by minus pi by 2 to pi by 2. This is the sin inverse x graph. If you see like that, for every function, that is cos, tan, cosecant, there is existing a inverse function. So what are the domains? You have to see clearly. So basically, the sin inverse x. What is the domain of sin inverse x? Minus pi by 2 to pi by 2. I will explain each and every graph. Sin inverse x minus pi by 2 to pi by 2. What is the range? Minus 1 to 1. And what is the cos inverse x graph? Cos inverse x domain is minus 1 to 1. Wait, 1 minute. Here domain is, this is for sin x. What about sin inverse x? Sin inverse x domain is minus 1 to 1 and range is minus pi by 2 to pi by 2. You cannot confuse in this, because in sin x you are taking the values of angles in the x-axis. So it is a domain minus pi by 2 to pi by 2 in sin x. But here in this sin inverse x, when you draw the inverse curve, you can get the domain as minus 1 comma 1 and also minus pi by 2 to pi by 2 as range in sin inverse x. And the next cos inverse x. What is the domain minus 1 to 1? What is the range? What is the range of cos x? Cos x range is 0 comma pi. Pi close. Next, after cos inverse, next is tan inverse x. Tan inverse, what is the domain? R. What is the range? Range is minus pi by 2 to pi by 2 open. And next, after tan inverse x, next to cot inverse x. Cot inverse domain R and range is 0 to pi. Next, secant inverse x. Cosecant inverse x. Minus infinity, minus 1, union 1 to infinity. 0 comma pi by 2, union pi by 2 comma pi by 2 comma pi close. Minus infinity comma minus 1, union 1 comma infinity. Minus pi by 2 comma 0, union 0 comma pi by 2. If you see the sin inverse x, cos inverse x, tan inverse x, cot inverse x, secant inverse x, cosecant inverse x. Basically, if you observe the one graph, this is sin inverse x. What is the domain? Minus 1 to 1. What is the range? Pi by 2 minus pi by 2. This is the curve for sin inverse x. And if you observe cos inverse x also, the inverse domain is minus 1 to 1 and the range is different here 0 to pi. And next, tan inverse x, domain is R, means you can keep any value in this domain. What is the graph of the tan x? This is a graph of tan inverse x, means tan x. This is tan inverse x, this like this, it is like this and it will be swap and it will come like this. This is a graph for tan inverse x. So when you observe, it is always 1 1, not many 1. So you cannot restrict the domain. So actual domain is the main answer. And also the secant inverse x. What is the graph of secant inverse x? If we take the secant inverse graph like this, it is a graph. How I am able to draw this graph? Because I know the cos graph. In the cos graph, this is a graph of cos x. At what point the cos graph ends, there it will start the sec inverse x graph. Like this graph will exist for sec inverse x. So basically you have to remember all these things, that is minus 1 to 1, minus pi by 2. I will do a question in the last where you have to apply these things. It is very important. Now, see, now graphs of all functions, that is sin inverse x, cos inverse x, secant inverse, tan inverse, cot inverse, cosecant inverse. If you see the graphs, first I already explained sin inverse x graphs, how it is like this now. This is a graph of here minus 1, 1, this is a domain minus 1 to 1, and what is the range? Minus pi by 2 to pi by 2. This is the range. Now cos inverse x graph. How will the cos inverse x graph will be? Like this. You already know. The cos x graph is like this. Actual cos x graph is like this. But when you restrict the domain, the graph is becoming like that. This is a graph. This is a graph for cos inverse x. You have to remember the graphs also. It is very important. And next third is tan inverse x. Tan inverse x means in pi by 2 it is not defined. You already know that. Pi by 2 and minus pi by 2. You have to draw a line here. When you draw lines here and starting from the negative x-axis, the graph here, it is not here. If we observe here, from here, the graph is like that. It is like this. It is very important to understand. It will not touch minus pi by 2, it will not touch pi by 2. It is the graph of like this. It is very important. And this is the tan inverse x graph. Then what about cot inverse x? Cot inverse x is, we can say the reciprocal. But here you have to check the values. At what values it is? Pi. At pi it is not defined. Because at pi cot 0. So at pi it is not touching. But at pi by 2, the answer is 0. Here 0 it is. You can assume like this. This is a graph. This is a graph of cot inverse x. This is pi by 2 value. This is cot inverse x. And next, sin inverse, cos inverse, tan inverse, cot inverse, secant inverse. You can definitely draw the secant inverse when you know that sin inverse. If this is a sin inverse graph now. At what point it ends? It will start like this graph. At what points and it is starting like this. If you rub this graph, this is a graph of this secant inverse x graph. Secant inverse not, it is a cosecant inverse. When we observe the sin inverse graph, I have drawn like this. And now that is secant inverse. Now also, at what point it ends? It starts like this. At what point it ends? It starts like this. So a graph is like this. You can easily draw these things. At what point it is? At what point it is? You already know that. This is pi by 2. This is minus pi by 2. You already know that. And at these values, the answer is 1. That is, here the answer is 1 and here the answer is minus 1. You already know these things. And also, where cosecant exists, cosecant inverse does not exist at 0 point. So there is no graph at 0. You can clearly visible that. These are all the 4 graphs of sin inverse x, cos inverse x, tan inverse x, cot inverse x, cosecant inverse x, next secant inverse x. These are all the graphs. Now let's get into the properties. I not taken any specified values on the number line. That is in the graph axis, I not taken any values. Why I am not taking the values? Because you have to remember the graph and at what points it is passing through x-axis and y-axis. That is enough. That is more than enough. Next, if they ask, you have to draw the original graph which I drawn here, and after that you have to keep some more points. That's it. That is more than enough. Now properties. Properties of ITF. What are the properties that exist in ITF? Basically, the properties is nothing but, first if we take sin inverse of minus x, what it will become? Like that, there is a set, sin inverse x, next cos inverse minus x, next tan inverse minus x, next fourth, cot inverse minus x, and next fifth, secant inverse minus x, and next sixth, what is sixth? Cosecant inverse. If you observe, sin inverse, tan inverse, cot inverse, secant inverse, cosecant inverse. If you observe these all things, you can definitely say that these all the things will emit minus to outside. Minus. But this function is very important. Tan inverse x also minus tan inverse x it will emit, and it also cot inverse x. It also secant inverse x. You have to check once. Secant inverse x also. This is a very important. Secant inverse x and cos inverse x is very important. When you apply minus x, it will come like this. Pi minus cos inverse x, it will come like this. Pi minus cos inverse x. And this also minus cosecant inverse x. It is very much important. Cos inverse for cos inverse, secant inverse. If you apply x place minus x, if we replace x as minus x, then it will come as pi minus cos inverse x. Like that. It is very important. And also, you already know that we can write like this. cosecant inverse x equal to 1 by sine inverse 1 by x. We can write like this. Cosecant inverse x equal to, and also the secant inverse x equal to, we can write cos inverse 1 by x. It is correct. And now cot inverse 1 by x equal to, there is a two possibilities here. One is tan inverse 1 by x or pi minus tan inverse 1 by x. There are two possibilities for cot. Pi minus not pi plus, because there is a restriction here. Why there is a restriction? For x is positive, we are writing tan inverse 1 by x. For x is negative, we have to write pi before the tan inverse 1 by x. It is mandatory. Why you are writing here? Why you are writing here? This is a reason. Cos inverse of minus x is nothing but pi minus cos inverse x. The value of this is completely depending on this. And also the cot inverse x also depending on these values. If x greater than 0, you can replace cot inverse x equal to 1 tan inverse 1 by x. But if x is negative, you have to keep pi in before tan inverse 1 by x. It is mandatory. And next, there are three main formulas now. That is, you already know that. Like this, sine square theta plus cos square theta equal to 1, there is formula now. Like that only in inverse functions also, sine inverse plus cos inverse equal to pi by 2. There is a formula. And also, and next formula is secant inverse x. Secant inverse x plus cosecant inverse x equal to pi by 2. There is a formula. And next, tan inverse x plus cot inverse x equal to pi by 2. These three formulas are important. And when these all are applicable, this secant inverse plus cosecant inverse is applicable when mod x greater than 1. It is important. And when this formula is applicable for x belongs to R, there is no restriction for this. And when it is applicable, you already know that sine inverse x, what is the domain? Minus 1 to 1. So when these all satisfy x values minus 1 to 1, you can apply this formula. And for all values of x, you can apply this formula. And for mod x greater than 1, that is x greater than 1, x less than minus 1. That is, if you see minus infinity to minus 1 union 1 to infinity, when there is a relation like that, you can apply this secant inverse x plus cosecant inverse x, that equal to pi by 2. Now let's discuss the important thing, that is sine of sine inverse x. It is very important. Sine of sine inverse x, cos of cos inverse x. When you do like this, the answer is x here. That is, the sine and sine inverse will get cancelled and the answer is x. And also tan of tan inverse x, that equal to cot of cot inverse x, that equal to x. You can write like this. And next, secant of secant inverse x, that equal to cosecant of cosecant inverse x. You can write x here. So basically you have to write like this. When there is a mixture of sine trigonometry and inverse trigonometry mixture, that is sine of sine inverse x and cos of cos inverse x. And there is a graph for this. Sine of sine inverse x, there is a graph. There is a graph. Sine of sine inverse x is nothing but x. So basically it is a straight line. So like this, there are all the graphs are same for this. But when it comes for reverse property, that is sine inverse of sine x. And next, cos inverse of cos x. Next, tan inverse of tan x. And next, cot inverse of cot x. When you do reverse property, that is sine of sine inverse x is nothing but x, but sine inverse of sine x is nothing but, you have to check in the graph. Sine inverse of sine x graph is like this. It is like Hill's graph. And this value is 0, this value is pi, this value is 2 pi, this value is 3 pi. And when it comes to cos inverse x, the graph is like that. Upper hills, there is no down. And this value is pi, this value is 0, this value is 2 pi, this value is 4 pi, this value is 6 pi. You have to remember these things. And next, tan inverse x. The next tan inverse x is like this. The graph is like this. 0, pi, 2 pi, 3 pi. This is a graph. And next for cot inverse x, same like this, but in cot inverse x, the 0 will not come. So all the values of tan x where it is 0, it will not occur the graph. So there is a breakdown of points like this. Like this it is. Cot inverse x. And also there are no downward points for cot inverse x. The reason for this you already know that. For cot inverse of cot x, the graph for cot x is what? Cot x is nothing but the at what values of tan it will not define. At cot it will not define. So you have to think like that. And also next cosecant inverse x, same graph, but there is a maximum minus of this. There is no point at 0 and there is no point at pi. Like this it will be breakdown. And next secant inverse x also same like this, but there is a point that will exist in middle where you can get like this. You have to check that. Next, at last I will do one problem for this. You can understand it better. What you have to do in that problems, it is very important. Next, there are interconversions. There are interconversions of ITF. That is, you can convert one inverse function into another inverse function. If we take an example, that is sine inverse. If we take an example sine inverse x, you can convert this into all the remaining forms. That is cos inverse x, tan inverse x, cot inverse x, secant inverse x, cosecant inverse x. For cosecant inverse x, you already know that. That is what? That is the cosecant inverse x is converted as cosecant inverse 1 by x. 1 by x. You can convert these forms, but here there is a change in values. That is sin x, and when it is changes to cos x, it is changes to cos inverse of root of 1 minus x square. Why it is like that? If we take this is alpha, then sin alpha equal to x na. If we take alpha here, x here, 1 here, what is this? 1 plus x square. Is this correct? No, it is not correct. We have to subtract 1 minus x square like this. Yes, now it is correct. If we take like this, sin alpha equal to x. Now, what about cos? What about cos? Cos is cos alpha. That is, what do we get? Root of 1 minus x square we will get. Alpha equal to what? Cos inverse of root of 1 minus x square. Like that, if we take secant inverse x, what is secant inverse x? 1 by root of 1 minus x square. Like that you have to do for everything. If we take cot inverse x, what it will come? This is opposite side, root of 1 minus x square divided by x. You have to remember these things. How I am doing? I taken right angle triangle and I taken sin inverse x is alpha, and alpha I have created a right angle triangle, and for this I created cos alpha, secant alpha, and after converting, suppose if we get cos alpha equal to root of 1 minus x square, what we have to do? Alpha we have to calculate. Alpha equal to what? Cos inverse 1 minus x square. And what is alpha? Alpha is sin inverse x. So therefore sin inverse x equal to cos inverse of root of 1 minus x square. You have to remember these things. Understand? Like that there is a conversions for this. You can convert each and every inverse function into another inverse function. And now let's get into the main part. That is, what about sin inverse x plus sin inverse y? How it will change? It is very important. The direct formula for this is sin inverse of x root 1 minus y square plus y root 1 minus x square. You have to remember this formula as it is. For this, there is a restriction. When you will apply like this, and there is a restriction for x and y values. If the value of x square plus y square less than or equal to 1, you have to apply this formula. And when x square plus y square value greater than or equal to 1, you have to apply same formula, but you have to keep pi in front of this. That's enough. And for same cos inverse x plus cos inverse y, what is the formula? Cos inverse of xy minus minus 1 minus x square into root of 1 minus y square. Understand? Here there is a slight difference. xy minus root of 1 minus x square into 1 minus y square. This is a formula for this cos inverse x plus cos inverse y. But more than this, the main important formula is this one. Tan inverse x is plus tan inverse y equal to tan inverse x plus y divided by 1 minus xy. This is a formula. When this formula is applicable, that is when x into y less than 0. It is important. When x into y less than 1, not 0, less than 1. And also, there is a slight shift in this formula, that is pi plus tan inverse x plus y divided by 1 minus xy when x into y greater than 1. It is important. When x into y, when we multiply two values of tan inverse, and if we get greater than 1, you have to apply pi plus tan inverse of x plus y divided by 1 minus xy. It is important. Now, the ITF chapter is completed. You have to learn this much only. This much is enough for inverse trigonometric functions. But you have to thorough with the domain and the graphs of sine inverse of sine x as well as the sine inverse. These all the things. Total how many graphs? 12 graphs is there. 12 graphs you have to master. And the conversions which I explained now is also very important. Now, trigonometric equations, the last topic. Trigonometric equations. What is an equation? If we take 2 cos x plus 3 sin y equal to 5, if we take like this, it is an equation. Why it is an equation? Because it is a combination of variables and also the numericals, and it is kept as a equal to form. So basically this combined thing is called equation because there is an equal to symbol. So when these types of equations we have to solve here, inverse this trigonometry and ITF will help to solve these trigonometric equations. So trigonometric equations is very important. There are certain procedures which you have to follow in order to do these things. I will explain each and every procedure now. Listen carefully. Basically in trigonometric functions, you have to see, that is, suppose if we take an example, that is sine theta equal to minus root 3 by 2. If we take an example like this, I have to find the solutions for this. Sine theta equal to minus root 3 by 2. Before that I have to explain one thing for you. If there is a curve here, rightmost, if that is alpha, the principal value of alpha, here pi minus alpha, here pi plus alpha, here 2 pi minus alpha. These four values you have to remember now only. Alpha, pi minus alpha, pi plus alpha, 2 pi minus alpha. What are these? These are the principal solutions. There are two types of solutions. One is principal solution and second is general solution. The principal solution will have the boundary of 0, 2 pi. You have to understand this. The principal solution have the boundary of 0, 2 pi. And for 0 it is closed and 2 pi it is open. It is very important. This is a principal solution. And also, how to find the principal solution? There are 3 steps. That is step 1, step 2, step 3. For step 1, what you have to do? Suppose I take an example, sin theta equal to minus root 3 by 2. You have to do the mod for this. That is minus of root 3 by 2. You will get root 3 by 2 now. At what value of theta you will get root 3 by 2? At what value of theta you will get root 3 by 2? That is pi by 3. And also minus root 3 by 2 is sign negative. Sign will negative in what quadrants? Third and fourth quadrants. So at third and fourth quadrants, you have to apply pi plus pi by 3 and 2 pi minus pi by 3. If we do this, 4 pi by 3 and you will get 5 pi by 3. And you have to take one value. And now you have to do the second step. The second step is you have to write the general solutions for sin x equal to sin y and cos x equal to sin alpha, cos x equal to cos alpha, tan x equal to tan alpha. There are solutions for this. The solution for this is minus 1. What are the solutions? N pi plus or minus 1 whole power n alpha. For this 2n pi plus or minus alpha. For this n pi plus alpha. It is very important. You have to check the what is plus, what is minus, you have to check. Now we are discussing the first one, that is sin x equal to sin alpha. What do you get? Sin x means sin pi by 3. Wow, we have gotten this. Equal to sin of alpha, what we get? 4 pi by 3. You have, for this you have to do use the formula for this. N pi plus or minus 1 whole power n alpha. N pi plus or minus 1 whole power n alpha, what we get? 4 pi by 3. So this is a solution set of for this sin theta equal to minus root 3 by 2. This is a procedure you have to follow. You have to see the what is principal solution, what is the general solution. The principal solution is nothing but the 0 to 2 pi. It is very important for doing the problems, and also it is the principal solution. What is the general solution? The remaining all solutions are called general solutions. What are the values that exist in behind the 0 to 2 pi? Those are the general solutions. And next, the principal solution means we are getting value. The general solution means this is n pi plus or minus 1 whole power n 4 pi by 3. I already explained sin x, cos x, tan x. Now we get into another form, that is where you will see that is sin square x equal to sin square y. Here we are getting squares. And next cos square x equal to cos square y. And next third, sin square x equal to sin square y, cos square equal to cos square y. Next tan square x equal to tan square y. You can clearly see that secant inverse x, cosecant inverse x, secant, cosecant and cot we are not discussing here at all, because in trigonometric equations the main role is sin, cos and tan. So there is no another thing. And now for these three there is a common solution, that is n pi plus or minus alpha. It is very important. N pi plus or minus alpha is the solution for sin x equal to sin square alpha. Like that, for the first thing, what we get? Sin x equal to sin alpha. Sin x equal to sin alpha, we got n pi plus minus 1 whole power n alpha. And for cos x, we got 2 n pi plus or minus alpha. For tan x, n pi plus alpha. That's it. But here you are getting n pi plus or minus alpha. This is the difference. And next, there are nearly 6 types in this. The pattern of trigonometric equations questions in JEE mains is total of 6 types. The first type is factorization. The meaning of this is, if we take like this, sin square x plus 5 sin x plus 6. If we take like this is a quadratic equation in x na, sin x na. So you can get roots as sin x plus 3 into sin x plus 2. When we do like these factors, it is nothing but factorization, and you have to equal to 0, and next sin x equal to minus 3, which is not possible. Sin x equal to minus 2, which is not possible. So there is no solution for this. You can say like that. This is the procedure. Factorization, you have to find the factors. If it is possible, you have to find the factors and you have to equate to 0 and you have to get 2 values. You have to check which value is permissible to write. That is sin x equal to minus 3. Sin x maximum value is 1 and minimum value is minus 1. So we cannot accept that. So minus 3 is wrong and minus 2 is also wrong. So that is the first procedure. And next, second procedure is a sin x plus b cos x. A sin x plus b cos x equal to c. If it is like this, you have to convert this as cos of x minus alpha, that equal to c by root of a square plus b square. You have to complete this equation into this type of form, that is cos of x minus alpha equal to c by root of a square plus b square. How we got this? We divided root of a square plus b square like this. When we divide, this thing is called what? This thing is sine, this thing is cos alpha, this is sin alpha. Why I am saying this like this? That is, if it is alpha, it is ba, it is b, it is a square plus b square, that is root of a square plus b square. And when you solve, that is a by root of a square plus b square, we got sin alpha. And when it is b by root of a square plus b square, we got cos alpha. Sin alpha, cos alpha, when we get into this equation, we got cos of x minus alpha, that is equal to c by root of a square plus b square. So if you got like this form, you have to convert this, and next we can solve. Suppose if we got x minus pi by 3, suppose if you got x minus pi by 3 equal to cos pi by 6, if you got, what I said for this, what is the solution? 2n pi plus or minus alpha na? 2n pi plus or minus alpha, what is alpha? Pi by 6. And also this is complete this value, so x minus pi by 3. What is x? n pi by 3 plus 2n pi plus or minus pi by 6. This is the answer for this. Like that you have to do. And next, this is type 2. And now type 3 problems are, we have to convert sum to product. Sum to product, and fourth one is product to sum. These are the two important things. Sum to product means if there is sin x plus sin y, if there is a sin x plus sin 3x is there, we have to convert the sum into product. How can you do? Sin c plus sin t formula is there na? 2 sin c plus d by 2 cos of e minus d by 2. There is formula na? You can apply this formula and convert into product. And when it is a product, you can convert it to sum according to the situation of the problem. We cannot explain the perfect situation here because the situations may change. So I cannot explain the problem for you here, but you have to do like that. When there is a sum, you have to mix the complete thing and you have to keep equal to 0 and you have to solve this complete equation easily. But when there is a product, you have to convert that into sum. Like this, there are two steps. And now the fifth step is using range of functions. Using range of functions. You already know for sin inverse x, what is the range? The range is minus pi by 2 to pi by 2. So you cannot exceed this range. So by using ranges, you can do the problems. So that's it. And another form is, if there are root questions, suppose sin x equal to root of sin 2x. Suppose if there is a question like that, you have to solve by taking both sides square, and you have to solve and make sure that what is a term present in this root should not be negative, always be positive. You have to check like that. The first condition is you have to for a root type of questions, you have to first check the domain of this thing, that is what is the present in under root, and you have to restrict the domain, that is it cannot be 0, it cannot be negative, it can be 0. So you have to keep sin 2x greater than 0, greater than or equal to 0, we can keep. It is first equation. And next equation is, you have to square this, sin square minus sin 2x, you have to solve. I already said if there is a sum or difference, you have to convert it into product and you have to solve. And when you solve these two things, the combination of these two solutions is a final solution. Final solution. Now let's discuss some problems in these ITF, trigonometric equations and trigonometry. In trigonometry, how many problems also you do? If there is a question, there is a twist in the question, you will suffer a lot. So that is the reason why so many people will leave the trigonometry after doing so many problems also. Some people will complete the complete book also. R.D. Sharma, those books some people do completely. But after that also, there might be a chance of not getting a correct answer in examination. The reason behind this is, in trigonometry, there may have the probability to come twist questions. You cannot expect the unexpected. You can say expect the unexpected. It is very important. Now let's discuss the problems one by one. The first one is cos inverse root of x square minus x plus 1 divided by root of sin inverse 2x minus 1 divided by 2. And this is, we have to find the domain for this. We have to find a domain. We have to find the domain and we have to report like this. Alpha comma beta is a domain, and what is a alpha plus beta? We have to report like this. Now the solution for this is, now we have to find the domain. I already in functions, I already explained how you are going to take these things. How do you find the domain? What is the use of wavy curve method? I already explained functions chapter. If you didn't watch those chapters. It is really important. And also, now let's get into this. If we take this thing, what is the main purpose of wavy curve method or the domain? The denominator should not be negative, no? So the first and foremost thing is sin inverse 2x minus 1 should be always greater than 0. And if you see this inequality, you can definitely see that sin inverse 2x minus 1 by 2. If we take this, sine inverse 2x minus 1 divided by 2. What is the range of the inside function? Suppose if we take sine inverse, suppose box, what is the range? But at how range it will come? The range of this is, suppose if we take the domain, what is the domain for this? That is minus 1 to 1 box. In box what is present? 2x minus 1 divided by 2 less than 1 less than minus 1. Some people do like that, but this is wrong. Why it is wrong? Because it should not be negative and it should not be 0, but it should be, it can be 1. So you have to keep 0 here, not minus 1. It is restricted here. Why? Because it is under root and also it is on the denominator, in the denominator. Now when you solve this thing, 0 less than 2x minus 1 less than 2, and when you solve this, 1 less than 2x less than 3, and x is from 1 by 2 to 3 by 2. This now keep aside. Now if we take this, x square minus x plus 1 greater than 0, you have to keep now upper also you have to keep positive because it is under root. When you keep this, suppose if we take x square minus x, what are the roots of this equation? 0 comma 1 na? This is a, and when we shift slightly, and when we shift like this, that is plus 1 you have to add, that is we are shifting like this, so it will come like this. Is it correct? It will come like this. Now what is the difference here? The roots are 0 to 1 na? So this is 0 to 1 and this is 1 by 2 to 3 by 2. Now we have to take the intersection. That is 0, that is 1, that is 3 by 2, that is 1 by 2 here, 0.5. Now it is from 0 point here and it is here. What is the range you have got? 1 by 2 to 1. This is a domain for this, alpha beta. And what is alpha plus beta? 1 by 2 plus 1, that is 3 by 2. This is the answer for this question. Now let's discuss the number of solutions concept. That is 7 cos square theta minus 3 sin square theta minus 2 cos square 2 cos square 2 theta equal to 2 in 0 comma 2 pi. Basically they given this equation and they asking for what values, how many solutions you will get into 0 comma 2 pi. You have to see like this. For cos square theta, can we change the cos square theta into anything? Can we change? 7 into 1 plus cos 2 theta by 2, can we write like this? Cos square theta? Yes. Here also 1 minus cos theta 2 theta divided by 2, can we write? Yes. Because there is a formula. What is the formula? Cos 2 theta equal to 2 cos square minus 1. So 1 plus cos 2 theta divided by 2 is nothing but cos square theta. So now we replace it like this. This is 2. And now when you solve this, suppose when you take the LCM complete 2, if you take LCM, this is it will become 4 and it will become 4. And when you solve, this is 7 plus cos 2 theta minus 3 plus 3 cos 2 theta minus 4 cos square 2 theta equal to 4. And when 7 minus 3 is 4 and 4 cancel here, and it will come 4 cos square 2 theta. This is 7 cos 2 theta, this is plus the, how much it will come? It will come minus 10 cos 2 theta, and when we common the cos 2 theta term, you will get 4 cos 2 theta, not cos 2 theta we cannot, we can take 2 cos 2 theta, we can get 2 cos 2 theta minus 5 is enough. Now we have to solve cos 2 theta equal to 0 and we have to solve cos 2 theta equal to 5 by 2. If we see the cos 2 theta equal to 5 by 2, it will coming 2.5. Cos theta cannot exceed the value 2.5, so it is wrong. So cos theta equal to 0, we have to check in between 0 to comma 2 pi. From this you can definitely say cos 2 theta equal to 0 na. Suppose if we assume this is t, cos t, if we observe 2 theta is from 0 to 2 pi. What about t? I am assuming this 2 theta as t, and we have to multiply this. For theta, what is the range? 0 comma 4 pi. If we take theta, the theta is moving from 0 to 2 pi. You will definitely see that cos 2 theta equal to 0 na, and theta is going from where to where? 0 to 2 pi. Now theta is going from 0 to 2 pi and I have to substitute 2 theta as t. and 2 theta is going from 0 to 4 pi. So cos of t is going from 0 to 4 pi. From 0 to 4 pi, cos t. Suppose if you draw the cos graph, like this graph if you draw, what you will get? Where the cos is getting 0? From 0 to 4 pi, this is 0, this is pi by 2, this is pi. That's it. This is pi by 2. Yes, pi by 2, this is pi. Okay, this is 3 pi by 2. Like this, you can get the answers. If we observe, this is 2 pi. If you observe from 0 to 2 pi, there are two solutions. There are two solutions where it is 0. So from 0 to 4 pi also it is two solutions. That total there are 4 solutions. You can say like this. So basically this is the important thing you have to understand. And also, so basically that's it. These two problems you have to understand. That is, one is the solution concept and the previous one is the ITF. The two I already discussed, and I have used the trigonometry formulas here. 1 plus 2 cos theta divided by 2, that I have already used. It is very important to mention. Here there is 2, but I have multiplied. You have to check here. But the answer here, this is for 4 only. It is important. So if anyone didn't join the Telegram group, join the Telegram group and download the complete notes, or you can scroll the notes and read and also practice the problems well. I hope you are doing the problems well, and this is the last session for the complete change makers batch. So I am feeling very happy that I have completed the complete syllabus for you for JEE 2023 one shots, and I also provided the short notes, and I also provided the Google Forms for you to practice. So I am very happy today that I have completed. My responsibility is over. Now it's your responsibility to show the power of yours, how much you have prepared. So I am saying all the best for everyone. So do the exams properly, do the revision properly, follow the lectures properly, and also the practice of problems properly. So that is the last thing I am going to say. But this is not over. For JEE 2023, there is so many things are coming in the future. Not in the future, so much future. In next few days or few months, you are going to get something big. Problem practice sessions, motivation sessions, and JEE student reactions, and JEE paper solutions. So much you can get from this. So if you like this video, subscribe to this channel and also hit the bell icon. So that's it for the video. Thank you.